Good afternoon, ladies and gentlemen. Up next, we have John Cantrell from C-Equals presenting Unleashing Bitcoin's Potential, a new approach to Lightning Network liquidity. John.
All right, good afternoon, everyone. Thanks for coming. Not close enough, all right. I'm going to talk about, like you said, a new approach to the liquidity on the Lightning Network. I'm John Cantrell. I worked under a grant from Spiral for a while on BDK and LDK projects, and then earlier this year, I joined the C-Equals team to work on Lightning and LSPs. So I'd like to start with on-chain Bitcoin, like talking about the UTXO model that it has. And if you're a new user and you download a self-custodial on-chain Bitcoin wallet, you get a receive address right away. If you fund it, you can always receive and you can always send. It just works basically, other than being a little slow and expensive sometimes. As long as you can sign your transaction and pay your transaction fees, there's nothing to stop you from transacting. And if we compare that to Lightning, at least before LSPs, it's more like you can sometimes send and you can sometimes receive. It just works as long as you have the liquidity. And so what do I mean by liquidity? What is this liquidity? Well, there's inbound liquidity, which is the amount of Bitcoin you can receive over a payment channel. And there's outbound liquidity, which is the amount of Bitcoin that you can send at any one time. And so how do you get this liquidity? How does it start? Well, it all kind of starts when you open a channel and connect to the Lightning Network. This gives you outbound liquidity and the ability to make payments on the network or send Bitcoin over the payment channel. One thing to note, though, is that you cannot receive initially if all you do is open a channel. And then as you send and receive or make payments over Lightning, this liquidity kind of flows back and forth between outbound and inbound on either side of the channel, depending on sort of the volume of sends and receives that you make. So what exactly is the liquidity problem? What's the problem with this situation? Well, one answer is, I guess one thing to talk about is if you're a new coiner, brand new to Bitcoin, you have no coins on chain or on Lightning or anything. You download a self-custodial Lightning wallet. You can't send or receive funds at all. It's a really shitty experience for a new person to Bitcoin. If you are a Bitcoiner, maybe you have funds on chain, and you open a channel and you're excited to use the Lightning Network, but you actually can't receive any funds right away. And this is also not a great experience. Maybe you're a merchant who sells things online and you'd love to sell on the Lightning Network. But what happens is since you receive more than you send, all the liquidity ends up on your side of the channel, and you consistently have problems receiving funds over Lightning. And that's sort of a huge problem if you're trying to be a merchant and receive funds for goods. Maybe you're a consumer who does more spending than you do receiving. You sort of have the reverse issue here, where all your liquidity gets pushed to the other side of the channel, and then you have issues spending. So this is sort of just a quick overview of the liquidity problem that people talk about on the Lightning Network. You really would prefer to have that on-chain UTXO model where you don't have to worry about any of this stuff, and you can always just send and receive. And so Lightning Network's been around for a while now, so what kind of solutions have people put in place to get around this? Because I did mention this is the experience without LSPs, but there are some really nice self-custodial Lightning experiences on Lightning today. Breeze has LSPD. It's an LSP they wrote that works on top of LND and gives inbound liquidity to Breeze wallet users. Phoenix has their Eclair, which is their node implementation, which also acts as an LSP for the users of the Phoenix wallet. BitKit built Blocktank, which is an open source LSP that anyone can run and provides liquidity to their BitKit users. Mutiny has Flow, which is a voltage product, which provides liquidity to anyone, but Mutiny has integrated it, I think, first. Blixt wallet has Thunder LSP, and Zeus has their Olympus LSP that they're rolling out soon. And so it looks like liquidity is solved on the Lightning Network. What's the problem? Why am I up here talking about liquidity? Well, if it wasn't obvious, it seems like pretty much every wallet ended up building their own custom solution to this liquidity problem. And so it's just a ton of duplicative effort that basically anyone who wants to build or wanted to build a self-custodial Lightning wallet in the past 5 years, and in theory forever, is going to have to do this. That's a huge waste of effort that these developers could be spending on new features and other interesting, product features for their wallets. And because they all have this custom unique solution to their wallet, it sort of creates this vendor lock-in problem. So in all of these wallets, as far as I'm aware, it's impossible to switch which LSP you're using. And because of that, it leads to sort of a privacy issue where because the single LSP is your only gateway to the Lightning Network, they're able to see every single payment that you make and receive. Additionally, since they're the only connection you have to the network, it sort of introduces a censorship vector where they could decide or be forced to stop forwarding your payments, which is basically, completely antithesis of Bitcoin, and we don't want that to happen. There's also this monopolistic effect it has. If they know you can't switch, they could price gouge you on their fees and charge unfair or non-market rates because there's not really a market because it's really difficult to switch. And so how can we fix these issues? Well, maybe a spec fixes this, or at least we hope. The idea would be once there's an open specification for LSPs, you would implement it one time, and this would work everywhere. And anyone who wants to be an LSP could implement this. And if your wallet needs liquidity, you could also implement this. And this solves that duplicative effort issue. And if every LSP speaks the same APIs and protocols, this would give wallet users the choice to switch LSPs at will, which helps solve that vendor lock-in problem. Additionally, wallet developers could support multiple LSPs at once, so you could do some kind of randomization or round robin on which LSP you use for each payment to help alleviate some of those privacy issues. And then lastly, it introduces some market efficiencies and makes it easier for LSPs, or kind of forces LSPs to be competitive. So it'll drive fees down and payment reliability up. Because if you're using a wallet and their LSP is unreliable and failing payments all the time or charging you too much, it should be pretty easy for you to switch to another LSP that is working better. So because it seemed like it was a good idea, about a year ago, folks from Breeze and Synonym and Nick, who leads the C-Equals team, formed an LSP specification group. They meet every other Wednesday, super early in the morning if you're on the East Coast. There's a Telegram group, a GitHub repo that has transcripts of all the meetings. A bunch of wallet and node implementations are represented in this group. If this is something that's interesting to you or you want to contribute, it's completely open. So come check it out and join the meetings and debate all sorts of minutia of LSP APIs. So let's jump into what is actually being specified. The first one is LSPS 0, which talks about the transport layer, the message structure, and the discovery mechanism. So if you're designing an API, you sort of need to figure out first, how are these participants that are using the API going to communicate? Early on in the group, they were leaning towards doing something like HTTP or gRPC because that's what they were already doing. But a few months ago, after a lot of debate, they decided to settle on the Lightning Bolt 8 transport layer. And the main reason for that is that every single wallet and LSP and application that wants to interact on the Lightning Network already speaks this transport layer. They already have the code to do it. And so why introduce new dependencies and complexities when they already, when they don't need to? And so it was sort of like, in some sense, the simplest solution. It uses a new custom message. The Lightning Bolt protocol specification outlines all sorts of messages that are used for opening channels and sending and receiving payments, but they also leave a ton of custom messages available to be used by protocol extensions and application-specific use cases like this. And so the LSP spec uses a single custom message. I don't think there's any significance to this type number that was chosen. It just had to be above, I think, 32,768 and be odd. And one interesting thing to me, at least, was that they used the single custom message, whereas all the other protocols in the bolts are specified over a set of messages. And the way they get away with that is by having the message payload be a JSON RPC request response. So the protocols are all like JSON RPC over a Lightning transport, which is kind of a cool trick and lets them implement basically an endless set of protocols over Lightning here. So other than the transport layer, they also talk about how do you figure out which nodes on the network are LSPs and what protocols and services do they support. So there's a new feature bit that you can put in your node announcement that says, hey, I'm offering LSP services on the network. And the first JSON RPC request is this list protocols request. So once you identify which nodes are offering services, you can ask them which protocols they support, because there's a handful of protocols that are being specified, and probably more in the future. This is something that you might not do in your wallet. I don't know. I assume a service like Amboss or other indexing services would index the list of LSPs and protocols they support. But the point is that anyone could listen to gossip and figure this out on their own. So the first actual protocol that is specified is LSPS1, which is sometimes called the Channel Request API. It's pretty straightforward and simple. Basically, it's just a protocol to purchase a channel from an LSP for a fee. And the flow is pretty straightforward as well. You basically ask the LSP for its channel parameters. These are things like min-max balance size. Does it support zero conf? Does it support zero channel reserve? So basically just like parameters about the channel that they're going to open to you, and what those are. And so if the client is okay with those parameters, they say, okay, great, I'd like to buy a channel from you for 1 million sats. The LSP responds with fee information, so how much it's going to cost you to open that channel. And they also provide on-chain and Lightning payment methods. So they'll give you an address and a Bolt 11 invoice that, when paid, the LSP is supposed to open the channel to you. And when the LSP determines that you have paid, whether it reached the minimum confirmations for on-chain payment, or they were able to claim the Lightning payment, then they open the channel to you. And so one thing that's interesting about, or maybe not so interesting about this protocol, is the trust model. It's basically that the client needs to trust the LSP. This is not using some kind of atomic swap or anything. It's basically like you're paying for goods and services, and you're trusting that they're going to deliver them. And so you're trusting that they're going to open the channel to you, that it's going to be the right size, that it's going to be reliable, that they're not going to close it right away. So it's going to be heavily sort of reputation-based, I guess, in this case. The second protocol is this JIT channels specification, which stands for just-in-time channels. Sometimes they're called on-demand channels. This is the really exciting protocol, in my opinion, because it allows someone brand new to Bitcoin who has no Bitcoin to onboard directly onto Lightning. So you're able to receive funds in your Lightning wallet without having a channel, without having to open a channel manually or think about liquidity or any of that. And the flow is sort of similar, at least to start. You ask for the fee and channel parameters from the LSP. If you're okay with the fee, you request a short channel ID. And with that short channel ID, your wallet's able to build a Bolt 11 invoice to receive funds like it would any other normal Lightning Bolt 11 invoice. The difference is that you take that short channel ID and the LSP's node, and you create a route hint in that invoice that tells the payer, you got to make sure that my payment goes through my LSP, essentially. Then the client is able to give out that invoice to whoever wants to pay them. Once the invoice is paid, the HTLC is going to traverse the network. It's going to reach the LSP because of that route hint. The LSP is going to unwrap the onion, see that it's supposed to forward this HTLC payment to over this SCID, the channel identified by the SCID that doesn't exist. So it's going to open the channel on demand. This is where this just-in-time or on-demand name comes from. It's going to take its fee and forward the rest to the recipient. And then the recipient receives the payment, reveals their pre-image to claim it, and the whole flow is done. And so if we want to take a look at the trust models for channels, there's actually 2 different models specified. The first one is one where the client also trusts the LSP. And the idea is that they release the pre-image immediately and hope that the channel that got opened, which is typically zero conf or hopefully zero conf, gets confirmed on chain. So again, there's trust here. You already have the channel open to you, so you can kind of you can see what the size is supposed to be. I guess they could lie about that too, but basically you're trusting that they're going to confirm the funding transaction on chain. There's a second model, which is LSP trust client, where the client doesn't actually have to trust the LSP, which is what I think we want. This is the default mode for this protocol. And the idea is that the LSP is supposed to broadcast the funding transaction immediately, but the big difference is that the client withholds the pre-image when they get it. So the channel's open to you, they forward you the payment, and you're supposed to release the pre-image, but you just hold on to it. So this is kind of like a HODL invoice, and you just hold on to it until you see that the funding transaction is confirmed on chain. And if you do that, now there's no trust, but you sort of lose this instantaneousness. Like you have to wait for the funding transaction to be confirmed. So the question is, can we get LSP trust client with zero conf? That would be the perfect situation. And that's sort of what LSPS3 is about. It's trying to find a way to create incentives that make the zero-conf channel open in the JIT channels safer by reducing the trust required by the wallet. And so the flow is pretty similar. It's basically the same flow. The client requests the channel. The LSP opens the zero-conf channel, forwards the payment. Again, the client withholds the pre-image, but instead of waiting for a funding transaction, the protocol specifies this get promise request. And the idea is that the LSP then signs a message that basically says, I promise to confirm this transaction with this ID by this block height. It's a little bit longer than that. And so once the client receives the signature for this message, then they reveal the preimage. So they're not really waiting for the funding transaction. They're just waiting to get a signature for this promise. And the idea here is that if the LSP fails to confirm the channel for whatever reason, the protocol defines this other request called report POM, which is proof of misbehavior. And so you can then, the client's wallet can then take that signature and the funding transaction information and tell every LSP on the network that this LSP misbehaved, and everyone can verify it cryptographically by verifying the signature and then checking the blockchain to make sure it's true. And then additionally, to kind of close the loop on this idea, is that every wallet could fetch all the proof of misbehaviors from all the LSPs using this download proof of misbehavior endpoint. And so that basically you can make sure that the LSPs you are using have never misbehaved before. So this sort of creates like a game theoretic solution to this. It's not perfect, but I would also argue that even without this, the incentives are sort of there for the LSP not to cheat. You know, LSPs are in the business to make money. They're taking these fees, and there's basically the first time that they cheat, their reputation is destroyed. And so this just kind of provides a little bit additional proof, basically, that they misbehaved, I guess, instead of just having the rough incentives be there. Then I'll jump to LSPS5, which is this webhook idea. Basically, the motivation behind this is that mobile Lightning wallets, when they're backgrounded, they don't get CPU cycles from the operating system, and you need to be online for a lot of operations in Lightning, like receiving payments, cooperatively closing channels, adjusting fee rates, et cetera. So you really want to be able to wake up the wallet when you need to do some of these things. And what's nice is that like the mobile application developer can do this by sending a push notification. The problem is we're trying to separate the wallet developer from the LSP. And so we needed a way for the LSP to be able to wake up the phone. And so this specification is really all about letting the wallet specify like a unique URL to the LSP that they can ping on the wallet application server over HTTP and trigger basically a push notification. So it's essentially a way for the LSP to trigger a push notification by going through the mobile application server. A little roundabout, but basically it's something we need if we want the LSP to be separate from the wallet provider and still be able to wake up the phone. All right, so we have the specifications. Those are the initial ones, at least. 0, 1, and 2 have been merged. 3, 4, and 5, they're still hashing out. Come join us if you want to continue hashing them out. But after specifications are merged, the next step is to actually go ahead and implement them so that you can use them with any node and wallet out there. And so I've been working on an LDK implementation of these specifications. It's a new library that works with basically any LDK-based node or wallet. And it implements both the wallet and LSP functionality. So if you wanted to spin up an LSP, you could use this. If you wanted to have a wallet that accesses this LSP API, you could do that as well. And we're looking to do LDK node support too, which is kind of a mobile-focused version of LDK. And this is a link to the GitHub, which you can't click on, but come up to me later if you're interested, and you can take a look at that. It's still very early. Everything's in PRs. But with that said, C launched on MunityNet this weekend, and we have our LSP running LSPS2. And I forked Mutiny, and well, it's a branch, I guess, of Mutiny that has also used that library to implement LSPS2. So you can try out an end-to-end flow of LSPS2 between Mutiny and C equals. And that's my talk. Any questions? Don't know if there's a mic. I see one over there, but. I was going to say, I forgot to mention, I spend a lot of time generating these images, so hopefully you enjoyed them at the very least. Yeah.
And I have two main comments. The first one is, isn't it premature? Doesn't all those specs because of political flexing and liquidity ads, which really make all of the liquidity specification become very simple, in my opinion, much simpler than what we have today. And the second one is support. Because right now you are splitting the role of the LSP from the wallet. Who handles support? How? And isn't it going to be a nightmare?
Good questions. In terms of splicing, I think that's something that we hope to work into the specs. In terms of liquidity ads, I'm not sure. I don't know. It wasn't discussed much in the year of discussions. Maybe that's something we should bring up and figure out how that fits in. If it fits in. In terms of support, again, that's going to be up to the wallet developers, I suppose, to figure out what relationship and they're the sort of the face of the LSPs, I guess, in this case, since the users shouldn't have to know about them. I mean, I'm sure there'll be some advanced wallets, like maybe Sparrow or something, will let you actually pick LSPs, but I imagine a lot of it will be hidden from the users, or at least I hope. Yeah, these are kind of unanswered questions, I guess, at this point.
Yeah, that can really be an issue because something doesn't work in the app and it's actually the LSP's an issue on the LSP.
Yep.
So you're not going to put a rating on your app. Your app is going to get trashed. You cannot do anything about it because it's the LSP's and that's something that you control.
Yeah, I mean, we see that today with some of these apps I listed here. They're running into problems with their LSPs, and yeah, it's up. I guess if a lot of companies use third-party services, and it's up to them to pick ones that are reliable. So they shouldn't offer unreliable LSPs in their app, I guess.
Thank you.
Yep.
Maybe you have some thoughts and comments on the original LNURL idea, which was also to scan QR code and get a channel. So I'm curious, because this is relatively similar to what a lot of these LSP specs are trying to describe, and maybe you have some experience or thoughts of why that wasn't enough, or whether it can succeed, or whether it can work, and how that is going to happen.
Yeah, I think there's maybe two things I have to say about that. Is one, I think a lot of the spec is very similar to what existing solutions are doing today. Like, it's not exactly a new solution. What is new is that it's trying to be standardized so that everyone doesn't have to keep re-implementing it slightly differently. In terms of LNURL itself, I don't have a strong opinion. I'm actually not very familiar with the different specifications over there. But maybe one answer would be back to this, like, it relies on HTTP, and maybe having something Lightning native is a better long-term solution.
How interested or averse have the incumbents been in having this standardized and not being their proprietary?
Yeah, that's a great question. For the ones we talked to, I mean, Breeze and Synonym were the ones who started this in the first place, really. And so they're hugely supportive and on board. They've been the ones doling it out in these chats and meetings for the last year. And I believe Mutiny is on board as well. I think a lot of them are. A lot of the wallets don't want to have to. As far as I'm aware, I can't speak for most of the wallets, but it's my understanding that they don't want to have to deal with this either. So. Anything else? Thank you.